Hello, everybody. Here we are, 3.5, dividing rational numbers. So first, some glossary terms, reciprocals. You might hear me refer to this colloquially. That's hard to say. Say that 3 times fast. As the flip. Okay, so you might just hear me say, okay, flip the second one or the flip. But it's two numbers whose product is 1. So product, remember, is the result of a multiplication question. So flipped fractions. 4 over 5 and 5 over 4. This is 4 over 5's reciprocal fraction. Because if you did 4 over 5 times 5 over 4, you would get 20 over 20 or 1. So that's a reciprocal. And another vocabulary word is quotient. So that's the answer to a division question. So we're looking at division today. Good for us to remember that a quotient is the answer to a division question. So a few notes. The same rules apply to dividing as they do to multiplying. And these are my smiley faces. I'll draw a grid for us. Okay. So let's say we got a positive and a negative here, a positive and a negative here. So these two, where it's both positive and a positive, that's a positive. Here, where it's a positive and a negative, that's a negative. Here, where it's a negative and a positive, that's a negative. And here, where it's a negative and a negative, that's a positive. So the same applies to dividing as it does to multiplying positive and negative integers and fractions. So when fractions are being divided, we instead multiply the reciprocal, or we multiply the flip sometimes, as I call it. So let's go. We got 1 over 5, and we are going to now multiply by the reciprocal of this fraction right here. So let's go times. Did I say divide? I meant times. We're going to times by the reciprocal, negative 5 over 2. Now we can multiply just like we usually do. Let's look diagonal, see if there's anything we can cross reduce. Indeed, we can. We got 2 5s across from each other. So I know 5 divided by 5 is 1, and 5 divided by 5 is 1 there. Then I can go 1 times negative 1 over 1 times 2, and we end up with negative 1 over 2. Let's do the next one. First, let's convert them into improper fractions. So remember, we multiply the denominator by the whole number, and we add the numerator. So 2 times 3 is 6, plus 1 is 7. That's over 2. Still divided by for the moment. Let's go 6 divided by 2, times 2, plus 1. So that's 12 plus 1 is 13, all over the same denominator. Now let's do our step where we flip, or where we take the reciprocal. So we've got 7 over 2 times now negative 6 over 13. And before we go any further, let's look diagonal, see if we can reduce anything we can. 2 and 6 have a common factor of 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. Now let's go 7 times 3. It's negative 3, is negative 21 over 1 times 13 is 13. And one final step, let's convert back to a mixed number. 13 can go into 21 once without going over. And the difference there is 8 over 13 left over. Okay. And finally, solving problems where an answer is given, but a piece of the question is missing. Okay, so we have the answer here, but we are missing a piece of the question. So first, this blank spot can be replaced with a variable. So we're solving now for x. And really, when we say equals blank, we are kind of solving for x as well, but here is going to help us to put the x here and then deal with our equation. Now we isolate the variable. We get it by itself. So when we're isolating a variable, we often do the opposite of bed mass. So first, if we can subtract, we subtract. If we can add, we can add. And then if we can multiply or divide,